It's my pleasure to present my research here, and I really thank the organizer for giving me the opportunity to present my research here. And I would like to talk about promising applications of iron-based materials in environmental remediation. Okay, now I would like to talk a brief background of my project. So, environmental pollution with various contaminants is being a worldwide problem day by day. The problem is particularly severe in developing countries due to unplanned industrialization, rapid urbanization, overpopulation growth, and intensive agricultural work. These activities release huge amounts of wastewater in the environment, and type of contaminants present in wastewater varies depending on the nature of the industry and the source of contaminants. Let us consider some aspects. Pollution by metal ions. The major pollutants found in industrial wastewater include cobalt, nickel, cadmium, zinc, copper, manganese, and excessive release of these metal ions cause huge environmental problems. They can cause severe health troubles, including cancer. So it is very essential to remove these pollutants from the water body. The second is metalloids or anions. Metalloids and anions are also significant environmental pollutants, and their toxicity is a serious environmental concern. And some pollutants are anionic species, for example, arsenic, chromium, phosphate, and selenium. Let us consider phosphate. Excessive amount of phosphate in water body can cause growth of algal, which can reduce the amount of dissolved oxygen that can kill fish and other aquatic animals. So it is very essential to remove these pollutants from the water body. Another one is pollution by dyes. My previous speaker already said about it. Textile and other allied industries release huge amounts of wastewater containing various organic dyes. These are extremely hazardous and carcinogenic to human health and aquatic life. Exposure to high levels of dyes can cause severe health troubles, including cancer. So it is very essential to remove these pollutants. Now the question is, how can we remove these pollutants? Well, simple, using nanotechnology-driven iron-based materials. Iron-based materials are the most abundant minerals in soil, sediment, and aquatic environments, and they have been used adsorbents because of their natural abundance, simple preparation, availability, low ecological impact, and the most interesting point is they have large specific surface area and low to moderate point of Zeusers and mesoporous morphology, which enable them to absorb a wide range of pollutants from the wastewater. So here I have shown several iron oxides in oxide forms, hydroxide forms, oxyhydroxide forms. So then synthesis, as I said, iron oxides are very simple to synthesize, and researchers have used numerous approaches to synthesize iron-based nanomaterials with suitable surface chemistry. Then comes the application of iron-based materials for removal of pollutants. The first one is heavy metal ions removal. So here is the list for the application of various iron-based materials for the removal of heavy metal ions. So from this table we see that a wide range of iron oxide materials have been used for the removal of metal ions, and their absorption capacity depends on the nature of iron oxides. And it is interesting to see that in most cases adsorption data fitted with Langmuir model and see the second order isotherm model. The second case is the removal of metalloids or anionic species. So here I have shown the list of iron-based materials used for the removal of anionic species. And here again, adsorption capacity depends on numerous factors including experimental conditions. Then comes dyes removal, and a list of materials used for the removal of dyes have been shown here. And it is also seen that a wide range of iron-based materials have been used for the removal of dyes from wastewater. We also found that miscellaneous pollutants have been removed using iron-based materials. For example, natural organic matter including humic acid, fulvic acid, phenolic compounds including phenol, nitrophenol, cresol, and some other compounds. Then comes adsorption data modeling. So in order to understand how pollutants bind to the surface, we try to fit adsorption data modeling. For example, we use adsorption kinetic models as our previous speaker already says about it. And we also study isotherm models. And this model gives information about the formation of multilayer or monolayer onto homogeneous or heterogeneous surface. Spectroscopic mechanism studies. Nowadays, spectroscopic analysis has been a popular tool for understanding the mechanism of adsorption onto iron-based minerals at molecular levels. And for example, several spectroscopic instruments have been used. For example, the scanning electron microscope, FTIR, ATI, FTIR, XPS, and X-ray absorption spectrophotometry. So, most cases, spectroscopic data and macroscopic data and spectroscopic studies have been considered for mechanism prediction. Then the most interesting part is the surface complexation model. Recently, surface complexation model has been a popular tool to understand how various pollutants bind onto the surface. We use several surface complexation models, for example, constant capacitance model, extended constant capacitance model, diffuse layer model, triple layer model, and here I have shown the list of papers where surface complexation models have been used for the application of iron-based materials for the removal of pollutants. In most cases, pollutants can bind to the surface by forming outer sphere complexation. In case of outer sphere, there must be a water molecules between adsorbate and surface. And in case of inner sphere complexation, there might be the involvement of direct chemical bond formation, and there is no involvement of water molecules. And here I have shown the prediction by surface complexation model. So it could be monodentate, protonated monodentate, bidentate or protonated bidentate outer sphere and inner sphere complexation. And then adsorption mechanism summary. So based on study, adsorption can be the adsorption of pollutants onto the surface can be electrostatic interaction, ligand combination, and precipitation, especially at high pH, and some other means of adsorption. So from this study, the key findings are a good number of studies have investigated that iron-based nanomaterials have potential for the removal of pollutants and contaminants for environmental management. And iron-based materials are excellent alternatives for effective contaminant removal. And however, uptake process depends on numerous factors, including experimental conditions and nature of iron oxides. And many studies deal with macroscopic data with adsorption kinetic and isotherm studies. However, only few deals with surface complexation and spectroscopic methods. So these are the reference from where most of the information have been gathered. And so here is my YouTube channel. My research activities can be found here. So
thank you, Dr. Aminul Islam, your nice presentation. Now floor is open for question, but by this time I warmly congratulate our chairman, BCSIR. He is with us.
Thank you. He is the man. He is a key person to inspire me sometime about the science and technology. Professor Dr. Aminulchem is my very close brother. Because of them, probably I am after Sheikh now in Bangladesh. And I am very grateful to him because when I